Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. What is the major product of these reactions? You can see this is a benzene, this is a propyl bromide, here in presence of anhydrous AlCl3. What is the product? By the way, by looking at these you can understand this is actually one aromatic electrophilic substitution where this proton is replaced by an alkyl group. So question how and why this is happening. So this we'll discuss. But before going to details, look at this question little carefully. That what kind of reaction? I've taken AlCl3, bromo derivative, substitution. So there is something else. What do I mean? So if you look at this bromo, actually this bromo coordinates with AlCl3. Now why? Because remember this AlCl3 is actually a covalent molecule, means this aluminium is attached with 3 chlorine atom. Now 3 chlorine atom with 3 single bonds, so you can expect each bond will provide 2 electrons. Since it's a covalent bond, so this aluminium will have total 6 electron in its outermost shell, although chlorine has 8 electrons. So I mean chlorine is octet filled, however the aluminium is not. So it is sextet. Sextet means you can say incomplete octet. So since it is incomplete octet, then it will like to have 2 more electrons and in order to complete its octet structure. So what it will do, it will accept a pair of electron. From where? So obviously from this bromine. Halogen have 3 lone pairs, so one of them will coordinate. Now after this coordination, aluminium will have octet. So in this case, this anhydrous AlCl3 acting as a Lewis acid and this bromine with its lone pair acting as Lewis base. Now after this coordination, what happens? So you can expect this bromine is getting a formal positive charge. One lone pair was donated, so till now 2 lone pairs still remaining. And since aluminium got one electron extra, so it will have a formal negative charge. Now halogen bromine is carrying the positive charge, means it is not that much stable. So what will happen? In this case, this bond will break and it will generate this carbocation plus BrAlCl3. Is it that much stable, this ion pair separation? No. I can say these are the intermediate produced and this intermediate will be consumed to something else. Now next, now here if you look at this aluminium center is octet filled because of this thing, so it's not that much unstable. But if you look at this carbocation, it is not at all that much stable. Why? Because it's a primary carbocation, and we know that stability order of carbocation is actually secondary greater than primary greater than tertiary, and I should include one another point, methyl cation. So here if possible this carbocation can rearrange to get secondary or tertiary, means primary can go there in order to attain higher stability. The same thing actually happens here. So one hydrogen from here migrates with its bond pair. I repeat, migrates with its bond pair, means 2 electron, resulting in a secondary carbocation formation. Means more stable carbocation produced, so that is the driving force for this second step. Now here this carbocation is actually electrophile and the reaction we are talking, that is Friedel-Crafts reaction, or more specifically if I say Friedel-Crafts alkylation. So this alkyl carbocation will react with benzene. So here if you look at, so this benzene reaction with this secondary carbocation produces, first it will produce a sigma complex and later on upon removal of the proton it will result this aromatic species. Okay, so from this benzene we will have 2-propyl benzene, so the option A is the right answer. Now if these questions appear in your exam, how can you solve it? By the way, if you look at very closely, option D and option C, they are dummy option. Real confusion is between option B and option A. Now in this case you need to understand one statement, carbocation rearrangement is possible in order to have more stable carbocation. So that is the driving force, so this is the product. By the way, this reagent has a particular name, it is called as cumene or sometime isopropyl benzene, and based on this there is actually a very famous name reaction, cumene phenol rearrangement or cumene phenol reaction, whatever you say. So in this reaction we get two valuable product, one is phenol and another is acetone. By the way, I have uploaded a dedicated lecture on this, please visit for further learning. But in cumene phenol process it is prepared in a different way, means they take benzene and they take propene and they take one source of acid, for example phosphoric acid, such that they can generate this carbocation in one step using acid. Okay, that's a different thing. I have already uploaded a dedicated lecture, you may visit for further learning. So today's discussion is over here. I believe this video may be useful. Thanks for watching. See you in my next video. Bye bye.